The thing we're looking at today is FloatCurve, and it's basically a data type that allows you to describe a curve. So it's a map of time to value. So you can see here it's a bit like that curve there, where we can put a load of keys in, a load of increments, and describe a curve like that. So you'd want to do that. So let's say you want the part to jump, and it has like an animation like that. The time would be sort of how long each one takes, and then the value would be what height it's at. So we can say when it gets to 1 second it should be there, then 2 seconds it should be there. So it's for that kind of thing. There's not many uses for this. Procedural movement is the one we've just looked at, and then it's basically the same as custom tweening. So with tween surface you can't do anything you want. That's where you'd use this kind of thing. So it can also be used for sound effects, so you could make the volume fade in, then out, then in, then out, and the same with camera effects if you wanted to slowly blur it out. So a float curve, which is the name of the curve that we make, it's made up of different keys, and each key has a time, so where it's at. So you can see that's at 0, 1, 2, and 3. Value, so what the value should be at that time. So we got 1, 2, so it's like a graph. And then the interpolation, which is how it should go to the next one. So if we had this key here, the interpolation says what does that bit look like to the next one. If we say it's constant, then it will stay at that line until it gets to there and it will jump straight up. If we say it's linear, then it's a straight line like that. And if it's cubic, then it will be like an actual curve. So that's the one that most people use. We can also have left tangent and right tangent, but that's completely optional. And it only matters if we do cubic. Basically, it describes how that looks, whether it comes in really sharp, and also how it goes away. But we're not going to look at those. Any questions so far? If I don't hear anything, I'll just carry on. So the reason why we need these when we have tween surface, with tween surface we can pick an instance or pick a part, and then we can pick the properties and what we want to set them to, and we can pick how long the changes should take and what way they should look. So we can pick from these: linear, sine, quad, bounce. But these are your only options. You can't make a custom sort of style, so that's why we use this. So the example we're going to use, we're going to have a part here. It starts at 0, 0, 0. We want to make it go up to 0, 5, 0. But we want it to be really complicated. So the kind of thing we're looking for is it sort of does that, and it's like a slow animation all the way up. And we can't use tween surface for that. So every float curve is on a chart with the two axes, the x being time, so that one there, and then the y being the value. So what we're going to use is as the x is always for time, but the y is going to be how high up the part has gone from 0 to 5. So it's going to look something like that. That's not exact, that's the kind of thing we're going to make. So the way we make it in code is we start by saying the curve is instance.new FloatCurve. And then when we want to make keys, we just say the key is FloatCurve.new, the time, the value, and then the interpolation. So if we do an example here, we make a curve by doing instance.new FloatCurve. It doesn't have to be parented to anything. And then a key. So let's say we wanted to make it starts at 0. We would say FloatCurveKey.new, and then we do the time, value, and interpolation. So it starts at 0. It also has a value of 0 because it's down here. And the interpolation, so the style to the next one, you can see it's cubic, it's not linear. And we do that with enum dot FloatCurve, key interpolation. And then we're going to do cubic. So that's the basic way to do it. After you have the key, you can insert it by doing the curve, insert key, key. So I could do curve, insert key, and then that one there. So that's the basic usage, but the way we're going to make it actually work is we're going to get the float curve, so make an empty curve, and then we're going to do set keys, and we're going to give it a list of keys. So you can see here we've made a key on each line and put a comma on the end. I'm just going to copy and paste that one in. So we'll put it here. And we now have the curve. So we have the script that describes that curve there. So now that we have the curve, we need to make the part follow it. To do this, we have to use the curve get value at time. So if we had this code here and we did float curve, so that one there, get value at time 3.5, it would give us this number. And that's about right, because if it's 3.5 in the middle of these two, we'd want it to be about 1.6 on the left there. So that's all the API stuff. We need to finally make it work, but any questions so far? So the way we're going to make it work, if I get the script up, we are going to start by making a function for the thing to go up. And we're going to say the starting time is tick. That just gives you the current time. There's other ways like os.time, but this is the exact one with the decimal on the end. We're then going to get the ending time, which is the starting time added with 10, because we know that this takes 10 seconds, because if you look at the chart, that's what we programmed in, 0 to 10. And we are going to have a while loop. We're just going to do while task.wait, so it runs forever. We are going to say the time that has currently elapsed, or the time that we've gone through, is the current time take away whenever we started at. And then if the amount of time that's elapsed is greater than or equal to 10, then we're going to break out of the loop. And for now, we're just going to print out how much time has gone through. And yeah, we're not going to wait again, because we've done that there. So if we just run this function and see what it does, you can see it's telling us exactly how much time it keeps on running, and that will carry on all the way to 10. So we're going to use this kind of thing the way we did at the bottom here, get the value at this time. So we're going to say the value over here, the value at the current time is the curve, get value at time, and then we know that that stores the correct time. Now that we have the time, I'm just going to get the part over here. And we're going to do the parts dot position becomes vector3.u. Remember at the start we said it's at 0, 0, 0, and it needs to go to 0, 5, 0. So it's 0, and then the value should be at this time 0. And if we run that function, then it will run the animation we made. It takes 10 seconds, but by the end of it, it will be at 5. There we go. Any questions on anything there?